Good morning. Chemical properties of hydrogen peroxide. In acidic conditions, hydrogen peroxide added hydrogen, added electrons, gives water molecules. For example, iron sulfate added sulfuric acid, added hydrogen peroxide, reaction to ferrous trisulfide, ferrous trisulfide plus water molecules. In basic conditions, acidic conditions, in acidic conditions, H plus ions, dilute sulfuric acid, H2SO4. Ferrous sulfate added sulfuric acid, added hydrogen peroxide, product ferrous trisulfide plus water molecules. Then in basic conditions, OH minus ions, hydrogen peroxide react to basic conditions. For example, potassium permanganate added hydrogen peroxide, product magnesium dioxide plus potassium hydroxide plus water molecules plus oxygen gas. Acidic medium example sulfuric acid, basic medium example potassium permanganate. Potassium permanganate added hydrogen peroxide, some product, additional water molecules. Acidic medium ferrous sulfate plus added sulfuric acid, added hydrogen peroxide, reaction to product ferrous sulfate, ferrous trisulfate plus water molecules. Uses of hydrogen peroxide. The oxidizing ability of hydrogen peroxide and the harmless nature of its product. Example, water and oxygen. Hydrogen peroxide, 2 molecules hydrogen, 2 molecules oxygen, led to its many applications. It is used in water treatment to oxides pollutions, as mild antiseptic, and as bleach in textile, paper and hair care industry, etc. Hydrogen peroxide is used to restore the white color of old paintings, which was lost due to the reaction of hydrogen sulfide in air with the white pigment. First one, hydrogen peroxide oxidize black color lead sulfide to white color lead sulfide, thereby restoring the color. Uh, this reaction, lead sulfur added hydrogen peroxide. Lead sulfide added hydrogen peroxide. Hydrogen molecules added sulfur, then added product to sulfide, lead sulfide plus water molecules. Structure of hydrogen peroxide. Both in gas phase and liquid phase, the molecule adopts a new conformation due to repulsive interaction of OH bonds with lone pair of electrons on each oxygen atom. In needed, it is smallest molecule known to show hindered rotation about a single bond. Hydrogen peroxide has a non-polar structure. Hydrogen peroxide has non-polar structure. The molecular dimension in the gas phase and solid phase differ as show the picture. In the solid phase of molecule, the dihedral angle reduced to 90.2 degree due to hydrogen bonding, and the oxygen bond oxygen to hydrogen angle expands from 94.8 degree to 101.9 degree. Expand oxygen to oxygen bond expand 94.8 degree to 101.9 degree expand oxygen to oxygen angle. One way explaining the shape of hydrogen peroxide is that the hydrogen atom should lie on the pages of a partially opened book and the oxygen atom along the spine. Next one, hydrides. three types of hydrides: ionic hydrides, covalent hydrides, metallic hydrides. What is mean by hydrides? Hydrogen forms binary hydrides with many electropositive elements including metals and non-metals. Hydrogen forms binary hydrides with many electropositive elements including metals and non-metals. It also forms ternary hydrides with two metals. Example, lithium boron hydride and lithium aluminum hydride. The hydrides are classified as ionic covalent and metallic hydrides according to the nature of bonding. Hydrides are formed with elements having lower electronegativity than hydrogen are often ionic, whereas with elements having higher electronegativity than hydrogen from covalent hydrides differ. Ionic hydrides. These are hydrides composition of an electropositive metal, generally an alkali or alkaline earth metal, except beryllium and magnesium formed by transfer of electrons from metal to hydrogen atom. Alkaline and alkali earth metals. Alkali metals: lithium, sodium, potassium, rubidium, cesium. Alkali metals. Alkaline earth metals: uh, beryllium, magnesium, calcium, strontium, boron, பேரியம் இதெல்லாம் வந்து alkaline metals, alkaline earth metals, except alkali metals or alkali earth metals except beryllium and magnesium. Beryllium and magnesium alkali earth metals except alkali earth metals, beryllium and magnesium. First, for example, first one, alkali metals, alkali lithium plus added hydrogen gives lithium hydride. Alkali earth metals example, calcium plus hydride, hydrogen, calcium hydride. Another example, beryllium, strontium plus hydrogen, strontium hydride. Barium plus hydrogen, barium hydride, etc. Then covalent or molecular hydride. There are compounds in which hydrogen is attached to another elements by sharing of electrons. Another elements by sharing of electrons. The most common examples. Covalent hydride of non-metal are methane, ammonia, water, and hydrogen chloride. Covalent hydrides are further divided into three categories: electron prices, electron deficient, electron rich hydrides. Examples. The last third one, metallic hydride. Metallic hydrides are usually obtained by hydrogenation of metals and alloys in which hydrogen occupies the industrial sites. Hence, they are called industrial hydrides. The hydrides show properties similar to parent metal and hence they are also known as metallic hydride. Most of the hydrides are non-stoichiometric with variable composition. Some are relatively light, expansive, and thermally unstable, which make them useful for hydrogen storage applications.